Hello, welcome to Tech Talk with Steve, episode 39. Today we're going to be talking about the importance of multi-gig SNR testing. The features that we're going to talk about today are functions that are available both in our Test Pro certification multifunction tester, as well as our network service assistant, which is a multifunction network tester. So you'll be able to use those on either of these products. Test Pro is the only product on the market, the only certifier on the market that has this capability. So it is very unique to us. And today I'm going to be joined by a special guest, Arvind Patel. Arvind is our Director of Engineering in the Test and Measurement Solutions division at AEM Precision Cable Test. He's a product engineer with over 20 years of experience in electronic circuits and RF systems. He's been involved in the design and implementation of test and measurement solutions for the cabling industry for the past 15 years. He holds a bachelor's of technology in electronics and communications engineering and a master's in electrical engineering from the National University of Singapore. Arvind loves to travel and being out in nature during his free time. Welcome, Arvind. We appreciate you being here.
Thank you, Steve.
So what I'm going to do real quick for everybody here is, since we're talking about the multi-gig SNR, I'm going to go ahead and and I'm going to run a quick multi-gig test here so we can see what we're talking about. And as this test runs, I'll explain it. You're used to seeing us talk about our 6-second Cat6a auto test. I'll preface this by letting everybody know this test takes a bit longer. And I've got this set up to run all the different connection speeds. So what we're going to do is we're going to do a connection test at 100 meg and 1 gig to make sure that we can connect. We'll do the same thing at 2.5 gig and at 5 gig and at 10 gig. And we do these different multi-gigabit speeds because there are different applications that use these different speeds. Wireless access points, for instance, you may have a couple of 2.5s or a 5 gig running to a WAP. That you need to test. And you can change the time that the whole test takes by deselecting whatever you don't need. So if you don't need to test 10 gig or you don't really need to test the 1 gig, you can just uncheck whatever you want and just leave the ones checked that you're testing. So during this test, we've done signal to noise ratio measurements, and Arvind is going to go into deep detail on these. But essentially what we're looking at here is the strength of the data that we're sending across this link. And it's a live link. I'm connected into a switch here. I could, in the absence of a switch, have a Test Pro remote on the other end and perform the same test. But we're looking at the strength of that signal and comparing that to the noise, essentially. And the noise is going to cause errors. And we're able to produce the results and give you this measurement of SNR. And with SNR, signal to noise ratio, the higher the number, the better. We want a higher number for SNR. As we approach 0, that's the limit for the IEEE, and Arvind will be talking more about that. But the limits are customizable. So if you want something a little better, you want to have like 3 dB, for instance, for your 10 gig, you can put that in your test limits. And additionally, we've tested these. If any of these were having problems, we could examine them by pair. So if we wanted to look at each pair on each of these speeds, we can see in detail what's going on with each pair. So if we had a number that was lower than we'd like, we can figure out which pair is related to that. We see we've connected fine at 1 gig and 100 meg. If you need SNR measurements for 1 gig and 100 meg, you can do that through the built-in side Ethernet port in the Test Pro or the NSA. And then we've also done a PoE load test at the same time, all in one auto test, that we can then save just like we do with our certification test. To run these tests in the Test Pro, I'm actually using this AD net cable adapter. It's got 2 RJ45 ports. One port is a convenience port for channel testing. So it's not just a multi-gig test adapter. You can also do channel testing out of this same adapter if you wish. The other port, again, is that multi-gigabit and PoE testing port that also allows you to access some of the network testing capability. And it just inserts into the back of your Test Pro. The AD NSA adapter that comes with the NSA is very similar to this. It's just programmed a little differently for the NSA platform. So that is the SNR test in a nutshell. And again, you can save this. You can provide it as built information for your customers. So if you're an installer or integrator and want to add some value add to your your portfolio for your customers, you can let them know, hey, in addition to certifying your copper cabling per the standards, we can also perform some additional testing to make sure your network link is working, make sure you've got PoE being delivered at the endpoint like you expect, and make sure that you don't have excessive noise relative to that signal. So I'm going to go ahead and stop sharing, and we'll switch this over to Arvind so he can get into some detail on his presentation.
So Steve, let me know once my screen is visible and I'll get
started.
See it.
Yep, you're there.
Okay, thank you, Steve.
You're welcome.
So we'll go through the measurements for using the TestPro's multi-gig adapter, and we'll try to understand what the SNR means in terms of qualifying and validating an installation. Right. So the Ethernet specifications are defined in the IEEE 802.3 working group. So all of the requirements for the complete Ethernet network gets initially defined and specified by the 802.3 working group. And these specifications are then taken up by the TIA and ISO working groups, and they in turn define specifications for the installations. So we look at the specifications that are defined in the IEEE. The first is the link segment characteristics. So this is essentially the parameters that we use for cable certification. Right? So a link segment would be a channel or a permanent link, which is just the cabling part. So we are not talking about the transmitter or the receiver, purely the installation. And this link segment characteristic would be the insertion loss, return loss, crosstalk, all the fixed measurements, delay, resistance. These are the parameters that are defined by the TIA and ISO for doing the channel and permanent link tests. In addition to that, the IEEE also has what is called a channel operating margin. This is a figure of merit for a channel, which essentially consists of a transmitter, a receiver, and the link under test. So basically, it would be a complete system, right? So the TestPro's SNR test is essentially this channel operating margin, which is a combination of a transmitter, receiver, as well as the installation of the cable. So we'll look into the details of what the channel operating margin means, and we'll look at some of the measurements later on. And then you also have the bit error rate test, which is in short popularly called as BERT test. This also is specified in the IEEE document. So all of these three methods, right, the link segment characteristic, the channel operating margin, as well as BERT, these are all valid tests. Each one of them has its own merits, advantages. There are also disadvantages for each of the tests, because not all tests encompass the full spectrum of the whole communication channel that you would want to test. So we'll first look at the link segment part of it. Steve explained this earlier about the channel and link testing. So the certification test essentially will do all the RF measurements. So this will be in TestPro, it is a 6-second auto test, which will do a measurement of all the parameters that are required by the ISO and the TIA standards, and which are also defined in the IEEE standard. Right. So this would be, as stated, insertion loss, return loss, next, which is the near end crosstalk, power sum next, ACRF, which is essentially FX minus the insertion loss, and then you have the power sum ACRF. There is a length limit for a channel, which is 100 meters for Cat6A. You have propagation delay, delay skew, loop resistance. This is becoming very critical for power over Ethernet measurements. And then you have TCL, essentially measures the immunity of the system, right, from external noise. This is a test pro view of a Cat6a auto test. So this has, right now there's a Cat, in the picture we have a Cat 8.1 adapter connected. So test pro is capable of doing that class 1 and class 2 test. A 6-second test will give you all of the measurements that you would need to qualify a cable for 10 gigabits. Right? So you have a detailed summary screen giving you all the parameters and the worst margin. The wire map is a live wire map. So as you connect the cable, the wire map will be displayed in real time. So you wouldn't need to do a test to be able to know if you have a good connection, right, for certification. The detailed test gives you all the plots as well as detailed information on margins for every pair combination. Right? So this will help you to narrow down to the pairs or a particular parameter that is marginal or what could be causing issues in the link. In addition to that, the certification part also includes diagnostics. So you can do return loss as well as crosstalk diagnostics, and it will tell you where the fault is along the cable or at the ends of the cable or at the connectors. Right? So this is all about the testing of a link segment. This does not test the transceivers. So the transmitter and receivers don't get tested as part of the cable certification. It's purely a link segment cable certification test, and it can be a channel or permanent link. We'll jump to the bit error rate test first to understand what it means, and then we'll go to the signal to noise ratio part of it. So a BER test, it uses predetermined patterns, and these patterns are various different sequences of ones and zeros to test the complete system. So the test, a BERT test would typically consist of a test pattern generator and a receiver, right? So the receiver needs to know what pattern it is getting. Otherwise, it will not know how to qualify it as a pass or a fail, right? So you have a picture on the bottom right which shows you like an eye diagram. So essentially, it is looking for the eye diagram opening becoming smaller. The part which is marked as A0, once it becomes 0, or you have a line that enters into the diamond shape in the middle, that's where you would have errors. So the BERT test will require you to use a pair of units. So you would need one transmitter and one receiver, and they need to know what pattern it is being transmitted so that it can decode accordingly. Also, you could use it as a single unit with a loop back at the remote end. Right? So there are two ways that a BERT test can be done. Right? You cannot use essentially a single unit would need a loop back, and a pair of units would need to know what type of pattern is being sent and what is being received. Now, the complexity of a BERT test is what we will explain in the table below. The requirement for a BERT test is that you need to have a BER of less than 10 raised to minus 12. What this means is that if you transmit 1 trillion bits of data, you can have only 1 bit in error, not more than that. Right? So that is the requirement of the Ethernet standard. So if you have a speed of 1 gigabits per second speed, which essentially means you are transmitting 1 billion bits per second, right? So 1 and 9 zeros. Now, if you need to test a BER, which is you need to transmit 1 trillion bits, right? That is 1 and 12 zeros. So to transmit that, it's going to take you 1000 seconds to transmit that 1 trillion bits. And that translates to about 16 minutes just to find that one error bit, right? And typically a BERT test will not just do one cycle of tests. They will do repeated tests to be able to at least about a hundred rounds of tests to be able to find an error in a BERT test. Right? So if you do that 100 times, that's about 27 hours for a BERT test at 1 gigabits. For higher speeds of 2.5 gig, that would be about 400 seconds to do to look for one error in 1 trillion bits, right? And that translates to about 11 hours of test time for that 100 round of BERT test to find a fault in a 2.5 gigabit link, right? And then you have for the 5 gigabits, that would be about 5.6 hours, and a 10 gigabit transmission you need about 2.8 hours, right? So this is, and the reason why I have put 100 times is that is typical of most of the BERT equipments, and typically uh, the BERT tests get done in the lab, right? Traditionally they have been used extensively for optical characterization, right? So the transmitters, receivers, and the link, right? End-to-end system, you do a BERT test, you qualify your system, right? But the downside is that it requires a whole lot of time, right? You need to run it overnight, or you need to run it over a very long period of time. So this is good for lab. Doing BERT test in the field can be a challenge because you would need to run this for a long time, and many times testing in the field is limited to at most maybe 10-15 minutes per link, right? I mean, for certification we have a 6-second auto test mainly for that reason, that a typical technician would be testing 200 links in a day, right? And they cannot afford to do a BERT test on every link because the test time would be just too much. They would not be able to even I'm not sure how many links they can do in a day if they try to do a BERT test, right? So going on to the channel operating margin, so this is one of those specifications given in the IEEE document. What the channel operating margin does is it is a combination of all of the parameters of a transmitter, the receiver, as well as the link under test, right? So if you look at this, it's a busy table, but the parameters that are defined in this table include, like, the frequency range, the loss values, the transmitter's voltage level, the receiver's voltage level, right? A whole lot of parameters that are being processed within the device at the ends in the transceivers, and it comes up with a single number, which is the channel operating margin, right? So this is a much more simpler approach to qualifying the complete end-to-end system. So in the test pro, the multi-gigabit signal to noise ratio is essentially a measurement of the channel operating margin. Okay? And what it reports is that 0 dB SNR corresponds to a BER of 10 raised to minus 12. So that is the definition. If you get a 0 dB SNR, it means you have a BER of 10 raised to minus 12. It's just that you don't need to do the BER test for that long duration, right? You just do a BER SNR test in the situation that you have, and it will tell you how good your communication link is. So COM, which is the channel operating margin, so that is, I would say, it's the complete budget combining the transmitter, receiver, and the channel, which is the the 100-meter channel or the 90-meter permanent link, right? So it's defined as 20 log of AS, that is a signal, divided by the noise. So if you have the signal level equal to the noise level, that would be log of 1, which is 0. So you get 0 dB would be the 10 raised to minus 12 level. And typically you would want to have a 3 dB margin for sufficient stability of the complete system, right? So this is a simply, I would say, a snapshot taken from the IEEE document, which defines what the channel operating margin or the SNR is, right? So it is a combination of the through measurements, which is the signal, and then you have crosstalk. So crosstalk would be near end crosstalk, far end crosstalk, all various combinations of fixed and next. And then you have the jitter. You have the data DDJ, which is the data dependent jitter, and then you have random jitter, right? So all of the noise combinations combining together, they contribute to the overall noise, and then you have the signal, right? So that ratio will give you the signal to noise ratio. So this is something that is defined in the standard, and it is a valid measurement to qualify a communication system, right? So in the Test Pro multi-gigabit signal to noise ratio, Steve gave a demo in the beginning, right? So this is essentially the same, where you do a test, it gives you the wire map of the system, the length of the cable, the signal to noise ratio at the various speeds, right? So all of this can be documented. If you've noticed, the limit defined is 0 dB. And when you do a test on 10 gigabit, you get 3.3 dB SNR. A 90 meter or 100 meter channel would typically give you better than 2 dB of margin, right? If you have 3 dB, that is very good. Now, the advantage of this system as compared to a BERT is that the SNR test can be done with the actual equipment in place. So you could have the Test Pro's multi-gig, the AD net cable adapter on one end, and you can connect it to a switch on the other end, right? This test cannot be done with a BERT system, right? In a need the equipment to be either looping back, or you need a transmitter and receiver that know what pattern is being transmitted and being received. So if you connect a BERT equipment to a switch, it might not be able to interpret the data correctly. So the SNR COM test is much more convenient, where you could have a single equipment like an NSA to be connected to a switch, and you do the SNR test, or you could have two units at either end, and it gives you the SNR for the whole system. This is the margin detail. So for each pair, you have 1, 2, 3, 6, 4, 5, 7, 8. Most of the time, the 3, 6, and 4, 5 combination is where you will have the worst margin, right? The lowest margin will be on those because of the split pair combination. So those are the areas that you need to take care of. In addition to that, Steve gave the demo. You also have the PoE measurements, right? So the PoE measurements would be these measurements get taken as part of the with this SNR operating. So it tells you how well the SNR performs when you have a PoE on the line, right? So sometimes what happens is the presence of PoE load can impact the SNR. So this can get tested at the same time. Now, many times it's hard for users to try to understand that whether a SNR test is a valid test as compared to a cable certification test. Right? So we have, I have one example which demonstrates and tries to correlate cable certification measurement with the SNR measurements. So we have a 95-meter channel which was having a limit on the insertion loss parameter, right? So that was the worst case parameter that was being measured. We had about 0.3 dB of margin on insertion loss. And the same channel was then tested for a signal to noise ratio test. Now uh, the table below gives you the SNR for the various speeds, right? So if you notice the 10 gigabit at pair 3.6 and 4.5, you have the lowest signal to noise ratio, which is 1.3 dB and 1.2 dB for the 3.6-4.5 combination. This is typical. 5 gig, 2.5 gig generally have very good margin. 2.5 gig is, in fact, actually the modulation scheme of 2.5 gig is even better than the 1 gigabit, right? So it is possible that you can have a link that works at 2.5 gig but does not work at 1 gig. That's because 2.5 gig is more robust in terms of its modulation techniques as compared to 1 gigabit. Okay. So after this 95-meter channel was measured, we added a additional segment of 7 meters to make it a 102-meter channel. So 102-meter is exceeding the standard limit of 100-meter channel, right? So just about on the borderline, I would say, slightly higher than 100. So the insertion loss started failing marginally, just about by tenths of a dB, 0.2 dB. And when we did the SNR test, we find that the 10 gigabit SNR also goes below zero, right? So zero is where you have the 10 raised to minus 12 BER specification. And here we have a minus 0.7 dB SNR for the 10 gigabit. So the 10 gigabit still works, even though you have an SNR of negative 0.7. So even though it works, it will have errors. It will have more errors. It is prone to alien crosstalk, right? So these are things that may not be clearly visible right away, but when cables are installed and laid out in a bundle, this can get worse, right? And if you are expecting an access point to work at 10 gig, it might not work at 10 gig and it might fall back to 5 gig or 2.5 gig. So it will negotiate down to a lower speed, which can be sustained on that link because of alien crosstalk. So this is a good test to sort of, I would say, validate the installations. Once you have everything laid out in place and you are observing issues or you want to have assurance of alien crosstalk. So once you have a bundle, you could use multiple equipments, check for the margin, and that will give you a good confidence in the installation that you have sufficient margin over the the requirements. So I think that's about it for the SNR measurements. Over to you, Steve. Thank you.
Thanks, Arvind. A couple of quick questions. And one of the things I noticed there, it seems that SNR test and BERT are using the same 10 to the minus 12 error rates, correct?
So, yes, that's correct.
So we're identifying the exact same problem. It's just a different approach to identify the problem. And we're doing it in a small fraction of the time as compared to an actual BERT test.
Yes. So the number 10 raised to minus 12 comes from the IEEE requirement, right? So they need the error rate to be 1 in a trillion bits, not more than that.
Gotcha.
So everybody developing an Ethernet system, it could be a switch vendor or someone who is developing, end equipment, or someone who is making cabling. The complete system, when everything is put together, cannot have an error of more than 1 in a trillion bits. That's the requirement. So you cannot violate that requirement.
Right, exactly. So, and looking back at that, I was thinking about those slides. You were anywhere from, almost 3 hours for 10 gig all the way up to about 27 hours roughly for a 1 gig. And I don't know if anybody timed it at the beginning when I ran the test, but I ran SNR for 2.5, 5, and 10 in about 43 seconds.
Yes.
And you can run the individuals in 20 to 25 seconds if you wanted to run just an individual one. So it's a much more expedient way to run that test when you're out in the field. And as Arvind pointed out, this could be used for troubleshooting should you be having issues on the network, but it could also be used as a supplement to your certification testing, where you're including additional information for the end customer as a value add.
Yes. So Steve, this BERT test is the traditional test which has existed for the last I would say 15 years. It has been there right from the from the initial Ethernet time, where for the optical systems at high speeds, the eye diagram method was always the way to test if the the system is working correctly.
Right.
Now, the SNR, let me jump to this. So the SNR method sort of is fairly new, and if you look at the information at the bottom where it says July 2012, so these are contributions that have made their way into the standards, I would say very recent. So this is more like last 7-8 years they have been incorporated into the IEEE standard.
Gotcha.
So BER is a test that has been there for a long time. The
Right.
SNR test is fairly new and it is recent. So I think everybody understood they wanted a simpler method that could incorporate all of the parameters and give you an overall number, and everybody works on that single SNR value to qualify their system. Because a chip vendor, a switch vendor needs to develop a system that will work with the cable, and it will also need to work with the end equipment. So all of them need a common language, so to say, and the SNR is a common language for all of them.
Right. And it's also much more expedient when you're troubleshooting in the field. You don't have time to leave your BERT tester sitting there overnight to gather data.
Yes.
Much
Yes.
more expedient.
Yeah.
Now, we did have one. Go ahead.
Yeah. No, I mean, leaving the BERT test on for the weekend is common. I mean, in
Right.
the labs, they do it all the time. But in the
Right.
field, it's not possible. I mean, in the field, you need to be done with a test in 6 seconds, 10 seconds.
Yeah, you want to get in and out. You want to find the problem, fix it, and move on to the next thing.
Yes.
So there was a question that came in, Arvind, asking about is the BERT framed or unframed?
Okay. Now, the BERT test, I mean, different equipments do it in a different way. This is, I mean, they have patterns, right? So end to end, they disable the error correction, and they send patterns from various stages of the PHY at different levels, right? So many times it is unframed, where it's just the pattern, the transceivers they send us a certain pattern and the receiver receives that pattern, right? The framed ones would be more like the RFC test, which is slightly at a higher level.
A more structured test, if you will.
Yes.
Like an RFC 2544?
Yes.
Okay. Gotcha. That makes sense. We've got a couple comments. Somebody said extremely insightful. And there's somebody wants to know if the deck's available. So if you want, you can email us. You can email me directly, steve.cowles@aem-test.com, or our customer care is customercare@aem-test.com. Or message me. I'll respond to you. If you've posted that via LinkedIn, I'll respond to you and give you my contact information, and I can get you a copy of Arvind's deck as well. Somebody else said, I'd like to watch this now, but I'm at work. We have it available later today, probably via on demand, so you can watch it afterwards. So that's really good information, Arvind. I think it's helped me a lot to understand a little bit better the comparison between the two. And we hear talks about BERT tests, being run in under a minute, but I don't know what that test is, because it seems like a BERT test, in order to provide a true BERT test, if it's going to provide meaningful information, takes quite a bit of time, as you've demonstrated here.
Yes. I mean, also, maybe I wanted to just add one more item, because we do have users who have been using this for alien crosstalk tests. Because, for example, if you have a Cat6 system, category 6 installations are limited to 55 meters for 10 gigabit operation. And if you have a cable bundle with varying lengths, so you might exceed that 55-meter limit on some of the runs, and you may want to do a alien crosstalk test. Now, an alien crosstalk test could also take you almost half a day just trying to complete alien crosstalk tests on cable bundles, because
that's why people don't do them.
yeah, I mean, they don't do. Now, the SNR test makes it very easy for them to sort of do this alien crosstalk test, because they can set this the transmission to 10 gigabit, and they can look at SNR at various speeds on the adjacent channels, right? So on one end, you could have a switch where you plug in all your cables, right? So you can have 6 around 1, so you have a 7-port switch, which is an actual switch that may be part of the installation. At the end point, you can hook up individual testers, so you can have like 6 testers, hook them up to the on the cabling, the 6 around 1 cables. On the victim, the inner cable, you set it to a 10 gigabit transmission, and then the adjacent cables, one by one, you can start turning them on, and you can see the impact of crosstalk from one cable to the other cable, and you would know how much is the SNR degrading, and whether it is a system that is susceptible to external noise.
Gotcha. And I would say that likewise, if you're just using one tester, one test pro or NSA doing an SNR test, and it's on an active network, where in that bundle you've got other active network devices that are operating, you're still getting what you're really getting there is a real world view of alien crosstalk impacting that victim cable, if you will, rather than a stressed view. Like if you put 7 testers together, you're doing a stressed view. But if you're doing one as the victim, and you've got other active network devices that are operating as their normal daily network operations would, you're doing a real world alien crosstalk test, correct?
Yes.
Gotcha.
I mean, this is giving you in real time on an actual installation, right?
Right.
The alien crosstalk tests defined in the standard are calculations, and I mean, they do give you meaningful results, but it's a very time consuming process, and nobody wants to do it in the field. You need a laptop, you need to hook up, collect data, do a test one by one. So I mean, because of the complexity, everybody avoids it. So if you really need to qualify test, I think this is a good way to know if your 10 gig will work or not. I mean, 10 gig is now becoming so common for access points. I mean, almost all runs to access points nowadays are 10 gigabit.
And it would be excellent if somebody has an existing Cat6 cable plant that they were previously running 5 gig, and now they want to test and see if they can run 10 gig. So they could do that using this methodology.
Yes. I mean, even a Cat 5e cable on 100 meters, it can actually do 10 gigabit, right? If you hook it up, just one cable by itself, it'll work. And many users may be under the impression that since it's working, they might as well leave it. But once you start bundling more and more cables together, and then interference starts coming in, it will suddenly downshift from 10 gig to say 5 or 2.5.
Yep.
Right? And unless you do this test and see it for yourself, you will never know that your installation is susceptible. I mean, this may be a case for cat 6 where you have this 55-meter limit for 10 gigabit.
Yeah, that makes sense, and that's good argument for using Cat 6A on new installations too. By the way,
Yes. I
much
mean,
more
for 10 gigabit, you absolutely should use Cat 6A. I mean, you don't want to be in a situation where you start seeing problems later. I mean, a typical installation gets a 10-year warranty, so you might as well use Cat 6A.
Yep. And I could see, with testing existing Cat 6, this would apply not just commercial, your normal structured cabling in a commercial building, but data centers where maybe they have some Cat 6 in the existing data center infrastructure and they're upgrading from 5 to 10 gig. And they want to test some of the legacy cable to see if they can support it. As you mentioned, in the varying runs, especially in a data center, those runs are going to be quite a variety of different lengths. In the data center, so it would have application there as well. So,
yes,
great. Well, Arvind, I really appreciate your time. We've run over a little bit, but I wanted to make sure that we did address some questions. And as I mentioned before, this was really, really good information, and I know I learned from it. Hopefully, everybody else who was in attendance or who's going to watch it on demand will learn as well. And we appreciate everybody joining us, and we will see you in 2 weeks on the next Tech Talk with Steve episode. Thank you very much.
Okay. Thank you.